People are having some difficulty with composites, and it comes down to a difficulty understanding just what function notation is telling you and evaluating a function at a given value. Okay? So we start with just a few simple examples. First one, you had f of x equal x squared, g of x equals 1 over x. So what's f of 2? Well, everybody is pretty comfortable telling, okay, f of 2 is 2 squared, so that's 4. Well, how do you know that f of 2 is 2 squared? Let's deconstruct this a little bit. When you write f of 2, you've replaced x by 2. Once you've replaced x by 2, you have to replace all your x's by 2 in the definition of function. So if 2 is going to go here, it's got to go here, so you're going to get 2 squared. Okay? Now you want to write that out. You don't want to just say it's equal to 4. I mean, it does, but you're used to evaluating this function. So you know it's 4, but you have to understand what you're doing. Okay, so we want to be very careful about this. So you get f of 2 literally means 2 squared, because x is replaced by 2, therefore this x has to also be 2, giving you 2 squared. That's why f of 2 equals 2 squared. And then, of course, the arithmetic tells us that 2 squared is 4. Okay, what's g of 2? Well, x has been replaced by 2. So you're going to have to replace this x by 2. You get 1 over 2, 1/2. And there's no simplification to that. You simplified the 2 squared, but that's already simplified. 1/2 is already simplified. Okay, now question, what's f of g of 2? Okay, well, f of g of 2, how do you get that? Well, g of 2 is 1/2, isn't it? So we replace g of 2 by 1/2. And now f of g of 2 seems to be f of 1/2. Now what's f of 1/2? Don't read anything into it, just literally, you got 1/2 here. F of x becomes f of 1/2 if x equals 1/2. So if f of x equals 1/2, then x squared is 1/2 squared, which is 1/4. Okay. What's g of f of 2? Well, what's f of 2? We figured it out, it's 4. F of 2 is 4, so g of f of 2 is g of 4. We just replace f of 2 by the quantity that it's equal to. Then, what's g of 4? Well, we look at the rule for g. X has been replaced by 4, so replace x by 4 and we get 1/4. You have to think about it like this. If you're thinking about it in any shortcut manner, you're not thinking the way that's going to help you when you have to do other composites. Okay? Okay, what's f of 2? Well, f of 2, let's see, that was 4, right? So replace f of 2 by 4. Now we have f of 4. What's f of 4? Well, the 4 has replaced the x. So you replace this x by 4 and you get 4 squared, and of course that's 16. Now you have to understand that. I won't say it's absolutely necessary to understand that. I will say if you understand that, then it becomes much easier to understand what we're doing next. Okay, so what we do next is the second problem on this worksheet, and incidentally this is the 170914 class. Okay. For f of x equals x squared and g of x equals 2 to the x, we want to find f of g of x and we want to find g of f of x. Now we do this very methodically because most people aren't very good at doing this yet. If you don't do it methodically, you're going to continue doing it by superstition or by misconception or something, but you're not likely or not as likely to get it right, and you're not likely to get it right as quickly as you would any other way. So, unless you totally understand this, do what I'm saying. Okay, so what's f of g of x? Well, let's look at the definition of f of x, okay? Well, in the definition, we have f of x, but we've replaced x by g of x. So we replace this x by g of x, the same as we did with numbers over here. And we get g of x squared. We don't do anything else. Ignore everything else. That's our first step. And that's all we're going to do with these functions all the way down. And then we'll go on from there, because you see we did, but don't worry about that. Because if you do, you're going to get confused. If you try to keep the formula for g of x in your memory is going to get cluttered up, and you're going to get confused about where the x squared goes, where the 2 to the x goes, and it's all going to get jumbled together, and it's likely, less likely to come out right. So all we do is we go up to this step. We don't pay any attention at all to the g of x function until we've done this. And g of f of x, it's the same thing. G of x is 2 to the x. If we replace x by f of x, then 2 to the x becomes 2 to the f of x. Okay, now that's equal to something, so, but we don't do that right now. We focus on the substitution step. Okay, now if f of x is the square root of x, g of x is 2 to the x, then, okay, f of g of x. We only look at the f of x. We don't pay any attention to g of x. We look at f of x. X has been replaced by g of x, so we better replace this x by g of x, which gives us the square root of g of x. And here, g of f of x, here's our g of x function. It looks like x has been replaced by f of x. So we replace this x by f of x to get 2 to the f of x. Now that's equal to something else. Again, don't worry about that yet. Okay, another example. F of x is 1 over x squared. So what's f of g of x? Well, x has been replaced by g of x. So replace x by g of x, and that's going to give us 1 over g of x squared. And then we've got g of f of x. What are we going to do with that? Well, we've got to look at g. G of x is square root of x. X has been replaced by f of x. So the square root of x will be replaced by the square root of f of x. Okay. That's the first step. You pay no attention to what g of x actually is here. You just write down what this is in terms of g of x. Then you can look at g of x, and we're going to do that. And when you're doing g of f of x, you don't worry about what f of x is. You look at the formula for g and substitute f of x for x. Okay? So we do that with every function. Now, since we're on this one, let's go a little further. Okay, now, we've got 1 over g of x squared. And now we've got no more reference to f, do we? So we don't ever have to worry about what f is. We've taken care of that. Now let's look at what g of x is. G of x is the square root of x. So g of x squared is the square root of x squared. So 1 over g of x squared is 1 over the square of the square root of x. And that's 1 over x, but there's something we've got to watch out for. I'm not going to talk about that right now. Okay, I'll come back and talk about that. Now, actually, since we're into this function, I'm going to talk about it, because I did this way in class. I'm not sure whether it's a good idea or a bad idea, but I'm going to go ahead and do it. Okay, you got to watch out for this 1 over x, because x is not allowed to be a negative number. Why is x not allowed to be a negative number? Well, because once you've got x, you evaluate g of x. And g of x is the square root of x, and you can't take the square root of a negative number. This means that negative numbers are not part of the domain of f of g of x because they're not legal for the g of x function. Even though in squaring this we've lost the square root, at the very beginning you weren't allowed to do that. And you're not allowed to do it here or here. In other words, x is not allowed to be a negative number. So, I say here a little more informally, watch it, because x can't be negative since g of x equals the square root of x. Okay? And then I say, i.e., the domain of this function, and that's a set of the x values that you can legally put into the function, is the closed interval from 0 to infinity. Doesn't include negative numbers. And that's just kind of a warning. You don't have to understand this in gory detail right now, but you should have a flag up here that you've got to watch for the domain. You've got to be careful that x is in the right domain. Otherwise, you can get ridiculous results. For example, if x is -6, or let's say -9, you can't take its square root. Okay? So you can't do this. But you could certainly do this, right? 1 over -9. Okay, but since this came from this, -9 is not permitted. Okay? Then g of f of x. Are there any problems here? Clearly, there are, because this isn't even defined if x is equal to 0. But the thing I want to kind of focus on here, because I didn't really mention the domain, I'm simply saying you have the absolute value signs around x for a very good reason. And what's that reason? Well, it's because again, here, well, you're doing g of f of x, right? Okay. I started explaining incorrectly. Okay, you're doing g of f of x. And f of x is 1 over x squared, and that's always positive. X squared is always positive, and if you divide 1 by a positive number, you always get a positive number. Okay? So, clearly, f of x is going to give you a positive number, and the square root of that positive number is going to be positive, right? Now, it's perfectly legal for x to be negative, okay? You could plug in -3. X squared would be 3, so you'd have, x squared would be 9, -3 squared is 9, so you'd have 1/9. And then you can plug that into the g of x function, take its square root, you get 1/3, okay? Now, if f of x is -3, then 1 over x, which is what you'd have if you didn't have the absolute value signs, there would be -1/3. Okay? You can't have a negative result here because from here on everything is positive. You put the absolute value signs around that and you find that the result is 1/3. So you might want to think about that. Okay, we'll look at the other examples in a minute because we're getting short on time here.